Hello everyone, welcome back. So let's see an example of weighted versus unweighted graph. Means in which case we might want to use weighted graph or which case we might want to use unweighted graph. So the represent actually how we want to represent a graph as weighted versus unweighted, that actually depends on the problem. All right. So let's come back again with the friendship graph in a social network. All right. So let's see, we have a couple of user. Okay, so let's just give some name and let's represent them just a circle. Okay, so A, B, C, D, E, F. All right, so let's see, one of the goal of this friendship network is that, let's say we're going to have some edges if they're friend. Okay, now let's see one of the goal of this friendship graph is that we want to make some suggestion of friend. Okay, so we want to have a application which want to give the user friend suggestion. Okay, now how do you want to suggest a friend? All right, so friend suggestion, suggesting a friend is also like it's a prediction problem. All right, but it is obviously going to use the current information. All right, means what is the current situation, what is the friendship information we have right now. And this information is also known as, another name of this problem is also known as link prediction. Okay, link prediction means, let's say here we have some existing link, like for example from A to B, A to C. Now whether can we predict that B or C might be a friend. All right, now based on this prediction we might want to suggest B that C could be, you might want to friend with C. All right, so Facebook actually does that, right? So in Facebook, actually, if you are a new user, obviously you are not going to have a lot of friends, but Facebook is going to suggest a friends based on your current friend list. All right, now in those problem, actually we might it might be a information, it might be useful information, how uh, strong is your friend with another person. For example, here, let's see, A is friend with B and A is friend with D. But these two friendship can be different. Okay. Now, one useful information might want we might look at that. What is the number of mutual friend between two friend? Okay. So for example, if A and B has like 80 mutual friend, where else A and D has a mutual friend like 5. Okay, so A and B has 80 mutual friend and A and D has 5 mutual friend. Now in this particular problem, this might be an useful information. Okay, because obviously you can see that A and B, I mean in those graph actually it means that A and B, they are friend and they have actually mutual friend 80. Okay, so obviously it is saying that they have a strong friendship. Maybe they are connected with like from college network, okay, college circle, or maybe they are related by a family. Okay, or maybe they are from the same family or maybe same circle, maybe school or from college. All right, so obviously A and B has a strong friendship than A and D. Okay, now if B is friend with another person, let's see a new person N. Okay, so B becomes friend with N. Okay, and D becomes newly friend with, let's see, M. Okay, so you might want to think that as A and B, they are so closely connected, so closely connected. Now B becomes a new friend with N, so there is a chance that A might also know N. Okay, so you might think that your application may suggest the node A to be friend with N. Okay, now D becomes friend with M, so there could be also a there could be also a chance that A might know M, but here, obviously, the friend suggestion between A and is going to be much stronger. Okay, so if you want to make a friend suggestion for a user A, okay, N and M, obviously N is going to be the topmost choice. Okay, all right. So in this particular problem, actually, the age of the weight is going to be important. Okay, and based on the problem, we are going to actually think about how we are going to assign weight for each age. All right. For example, here number of mutual friend can be a associated weight for each age. Okay, in this particular problem. All right. Now, the same example, let's think about the same graph, say friendship graph. Okay, like here we have a couple of other people, say N1, N2, N3. Okay, so let's see what the A graph looks like this. Okay. So here actually from this graph, we can see that actually here we can find one community, here we can find another community, and there is a weak tie between this community and this community. Okay, so if the problem says that like you have a network, like friendship network, all right, social network, you have to find some community, closely tied community. In that case, maybe just the information, whether who is connected with who is connected with who, that's the only information we need. Okay, so for example, here we can see that here we have a community, here we have another community. Okay, by community means actually cluster. Okay, so cluster means actually in one cluster, there is going to be a lot of connection between each node. Okay, and there is going to be a less connection between two different clusters. All right. So in this example, we are not going to need any weight. All right. That means that only the information that who is connected with who is actually all we need. All right. So in an unweighted graph, what it means that every edge has the same weight. All right. Or we can say that the weight of the edge is not important for a particular problem. All right.